Okay, so this one says, without dividing, use the factor remainder theorem. So you have to know what that is. And that's just plug in the number to see what you get out. So what is the root number? 4. The root number is 4. So there, did we get it? Is that it? It could be in that section, but they probably would give you smaller numbers. So if I had some further questions, what would you conclude? This is not a factor. You can say this is not a root or x-intercept, right? Because the remainder does not equal 0. Okay, write a division statement at the end. So this means you're going to be doing a synthetic division with the root number in the front. What should you check before you write? Anybody remember this secret? Is there any gaps? 3, 2, 1. No, there's no gaps. Okay, so you start by bringing the first thing down. Times, add, times, add, times, add. Okay, so if I wrote a division statement, it would be, I have to do this divided by this equals, how do you read this result? 3 what?
3x squared.
X squared. That's an x, that's a number. This is a remainder over the factor. Okay, this is called a division statement, but what if the word said write the quotient? Then you, boom, just that. That's the quotient, just that part. Okay, find the equation. Okay, y equals some multiplier, don't know yet. Okay, here is an x-intercept at -2, so I'm going to write a factor x plus 2. Then there's an x-intercept at 1, so I'm going to write the factor x minus 1. Then there's an x-intercept at 3, so I'm going to write x minus 3, bouncing. Do you understand what degree this is? It's a 4th degree, and what do you know right now in front? There will be a negative something in front. Okay, so now what I'm going to do is I'm going to plug this point in. So I'm going to replace y with 36, and I'm going to replace x with 0. I replaced x with 0, right? You see that? That's what I did. and I need you to multiply that entire thing on that side. This is without your calculator too. Did you get negative 18? That's positive 9 times negative 2. Okay, so now you have to write a final equation. Okay, I also expect you know how to graph. If I give you this equation, do you know how to graph it, right? I don't think I put any of those on here, but. Okay, graph this. So, how do you start if you were giving just nothing? You were given no info. Trial and error, test something. So I'm going to start with 1. If x equals 1. 1 cubed minus 7 times 1 plus 6 equals 0. Oh, that's nice. So what do I know? I know that there's an x-intercept at 1. What are some other things I know? X minus 1 is a factor, right? So those are some things I know. Where do I go with that info though? Start dividing. So the root number that I'm picking is a 1. Griff said we should check for gaps. There's some gaps. I have 1 for cubic. I have no squareds. So what does that mean? That's that. Don't forget what? It's times by that yet, right? Because this is cubic. So now I have this squared times this x was making this cubic. Now you should be able to break that down by hand. What are some things we know about it? X cubed. I know the shape. I know the arrows. I know the y-intercept is 6. How else do you find y-intercepts? Plugging 0 in. Okay, so be careful with questions. Some questions might say list all the factors. So if I said list all the factors, that's my answer. If it said list all the x-intercepts, then this is my answer, right? You have to just be careful what the question is saying. Okay. One other quick question that I might have done is I might have given you this and you had to figure out what the original equation was. Remember that question? Just work yourself backwards in your synthetic. Okay, and then we'll do one kind of box question here. Okay, so do you remember what this one was about? You took a piece of paper and it was 6 centimeters and then you cut the corners out. And then you flipped the corners and made a box with it. Okay, so what is that little space there once I flip it? 6 minus 2x. And same. And then the height after you flip it is x. Volume equals length times width times height. You could also do this on that one. Model it with a graph. So what's the x-intercept on that bracket? What causes that to be 0? 3. And 0. It's a cubic, so there's a bounce here, remember? Squared, there's a bounce. And we need to discuss the domain. So x. X is me cutting off an amount. So we can't have negative x, right? X negative, not good. Can you have an x of 0? Can you cut 0 off? No. You can't be on 0, so you can be anything just above 0. Can you cut off more than 3? No, because if you cut off, let's say 4 and 4, that's not even possible, because that's cutting off 8, but there was only 6 there. So you can't cut off any more than 3. Can you cut off exactly 3? No, because then you're turning your side into a 0. Can't have a 0 on a box. So technically your graph would end up just looking like that. But and estimate the max volume. So what do I do when I'm trying to find a max? I don't know exactly where it is. It's in this zone. And I kind of use an approximation, so I just pick an x value to try. And if it's between 0 and 3 somewhere, I just say, well, what about 1.5? So that's what I do. I plug in 1.5. Okay, and then I'm telling you that it's in cubic centimeters because we're talking about a max volume.